Morning, good afternoon, good evening, everybody, to different parts of the world. Today we'll be looking at depressurization, more particularly bird strike. Also specifically looking at technique for the ICAO exams in answering questions about depressurization. Also to give you some ideas as to how you can respond in the actual exam. Okay, moving through today. This presentation will take about 90 minutes. Here we go. So let's start off with depressurization, bird strike. What we're actually looking at today is, and also what I want to point out to you is we're going to use some videos. And the idea in showing you the videos is if you don't have experience, we're showing you these videos to explain a situation, to give you ideas. And that way you can tell the story in the ICAO exam and become the expert. Remember, you can be an expert if you can explain and express an opinion by talking about examples. So use the videos for ideas and examples. And of course, if you need to play this class again or watch the video again, this is a perfect opportunity here on the learning platform. So let's start off with depressurization. And first of all, what I'd like to do is take a look at the photograph that you see on the screen. This is of an explosive depressurization, decompression of a Qantas 747 cargo hold. The aircraft, Qantas Flight 30, was flying, 2008, was operating a scheduled flight from London Heathrow to Melbourne, Australia, with a stopover in Hong Kong. The flight was interrupted on the Hong Kong leg by an exploding oxygen tank that ruptured the fuselage just forward of the starboard wing root. And you're probably going, starboard? I remember that word, but what does it mean? Well, we're talking about here starboard, the right-hand side. So when we're talking about the starboard, if you recall, all right, starboard equals right. So if I'm looking at my aircraft as I see here, starboard is the right-hand side, port is the left-hand side. So many times in aviation, to reinforce what we've said before in our ground operations class, if you're flying London, Europe, a controller or a pilot might use the word, I got a problem with the starboard engine, instead of saying engine number 2 or the right engine. Or he might say, I've got a problem with the port gear, the port undercarriage, the left gear. Now for ICAO, International Civil Aviation Organization, the exam that is accredited, your exam is accredited by ICAO, we need to know this vocabulary. Also, very common in the English language, when we hear a sound, we might use the word thud. And here, the passenger above said he heard a loud thud. Remember, thud is like in Spanish, we say sonido suave. For example, I heard 3 thuds. What do you think that was? Bird strike, impacto de aves. I heard a thud. Teache. Now,
flight from London to Australia has been forced to make a bumpy landing in the Philippines after something punched a hole in its fuselage. More than 300 shaken but unharmed passengers have been escorted off the plane while engineers try to work out exactly what happened. Sky's Mark Stone is with me in the studio here. The pictures are scary stuff.
They are very scary stuff. This was Qantas flight QF30 that left London, we understand, about 12:53 yesterday afternoon. Bound for Hong Kong, first of all. It landed in Hong Kong at 7:30 this morning, local time. Took off an hour and a half later this morning, 9 o'clock, and was due to land in Melbourne at 9:45 tonight. It didn't, though. It made this emergency landing in Manila because of this big hole that we can see here. I think if we pause on this shot here, we can see, if I can get the machine working, that there is a distance, we think, of about 2.5–3 meters. So it is a very large hole.
Meters?
Yeah.
It's 7 feet.
It's big. Beneath.
Notice on the top of the PowerPoint, the vocabulary. Now we used and introduced the word bumpy in the word in weather, and that's generally used in the English language. We had a bumpy landing instead of saying a turbulent landing. And also we're using the word, as you see here, after something punched a hole in the fuselage. Loss of cabin pressurization, depressurization, decompression is a possible situation, an unexpected event. Are we prepared for it when it happens? Normally when it happens, it can be, for example,
We had a sudden cabin depressurization and are making an emergency descent.
What we need to note here, for the purposes of a readback in an ICAO exam, not necessarily from the flight deck, is what type of depressurization was it? So the word sudden or rapid is important. Why is it important? Because it tells it happened quickly, therefore was unexpected, therefore maybe some passengers or cabin crew were injured, and therefore might need medical attention. That's what sudden is, rapid. So that word's very important for us when we're reading back in an ICAO exam. And the consequence of which is we're making an emergency descent. So please be aware of these two words, rapid and sudden, in your readbacks in the exam. Do not omit them when you hear them in context. We had a sudden depressurization, we had a rapid depressurization. You need to read back all the information.
We had a sudden cabin depressurization and are making an emergency descent.
Also, the word cabin identifies it was in the cabin, not on the flight deck. Now, we also need to understand some basics on how aircraft are pressurized. So I've taken this opportunity to dig into one of my old handbooks, and I've got a video class here I want to share with you. It takes a few minutes, but for those of you that don't know how we pressurize an aircraft and why we have to pressurize, this is a great explanation. Follow it through.
The jet aircraft are the fastest and the most efficient at high altitudes, where they can benefit from lower air resistance. As the airplanes started to reach higher cruising altitudes though, it quickly became apparent that it will be necessary to protect the crew and passengers from the number of physiological problems caused by the low outside air pressure. The air mainly consists of molecules of oxygen, nitrogen and argon. The concentration of oxygen in the air is around 21% and remains constant to 100 kilometers. But as the aircraft climbs, the atmospheric pressure decreases exponentially. At 16,000 feet, the pressure is about half of the pressure at sea level, and only a third at 30,000 feet, the summit of Mount Everest. As the atmospheric pressure drops, so does the partial pressure of the oxygen. This means that the oxygen molecules get further apart and we get less of it every time we breathe in. When unprotected, climbing to high altitudes, the human body would experience oxygen deprivation, or hypoxia, starting with impaired thinking and vision, hyperventilation, loss of consciousness, and ultimately death. The lower the air pressure, the faster and more pronounced the effects are. While at 25,000 feet we could function without any difficulties for around 3 minutes, at 41,000 feet it's only 10 seconds. We call it the time of useful consciousness. So why is that we can fly day to day at cruising altitudes of 41,000 feet, well above the summit of the highest mountain in the world, without being attached to the oxygen? Well, it's because the aircraft cabin is pressurized and the cabin altitude is kept well below the ambient one. Most of the airliners are utilizing the biggest compressors there are available to pressurize the passenger cabin, the jet engine. This is CFM 56-7B26, engine powering the Boeing 737. It has a set of compressor blades mounted on a disc, rotating at very high speed, up to 15,000 RPM. These discs follow one another and are there primarily to compress the air for combustion and to create thrust, but we can use some of it to pressurize the cabin. In this engine, the air from 5th and 9th high pressure compressor stages is extracted into the bleed air system. The air from the compressor can reach temperatures of up to 232 degrees Celsius or 450 degrees Fahrenheit, with peak pressure of 60 psi, too hot to be supplied to the cabin just yet. That's why the air goes into so-called pressurization and air conditioning kit, or more commonly known the pack, before it can be supplied into the cabin. The hot bleed air enters the pack, where it goes through a set of heat exchangers which are cooled by the outside rum air. From there, the bleed air continues to the air cycle machine, where the air expands and cools down further. This whole process refrigerates the air to pleasant air temperatures. Should the air however be too cold now, the pack would use a bit of bleed air which bypasses the refrigeration process to warm it up a bit. To make the air conditioning and pressurization system redundant and to be able to meet the air supply demand, there are two packs installed. Now that the air is at room temperature, the only thing left to do is to distribute it. Our Boeing jet distributes air from two packs into 3 zones.
What you're hearing?
The jet aircraft are.
What you're hearing in this video is some essential vocabulary. The exams that we take are not technical exams for ICAO. So the type of words that we need to identify with are bleed air, air conditioning pack. For example, we could say, we've got a problem with the air conditioning pack. Now, you've just learned from the video what the air conditioning pack does. Also, you've learned also that the temperature is distributed into the cabin in 3 areas: aft, front, and flight deck. Each of those has a thermostat to control temperature. For example, if we hear a potential problem, we've got a problem with the thermostat. Our first question would be, which thermostat has the problem, front, rear, or flight deck? And then we get into the actual details that way around. In looking at our focus for the exam, we need to keep an eye on this. What are some of the possible causes of cabin depressurization or sudden depressurization? These are the topics we're going to overview today. For example, bird strike, the puncture of the fuselage, breaking the cockpit windscreen, hailstorm, granizo, bad adverse weather, puncture of the fuselage, breaking the cockpit window, a possibility, bad weather, a lightning strike, dangerous goods. Here's the abbreviation HAZMAT instead of hazardous materials. Also, failure to secure the cabin door or failure of a window, failure to set the cabin pressurization switch to auto, the engine exploding and debris shattering the window, causing a depressurization, and metal fatigue, corrosion due to poor maintenance. All of these we're going to take a look at today to give you some idea of how you can respond and talk as an expert about depressurization, its effects and the procedures. How do we prevent it? Well, number one way around it is, first of all, a routine and detailed maintenance check. That's essential. And so depending on the age of your aircraft, most aircraft go through a complete check where we take out all the seats, take out all the bulkheads, check everything. And that normally happens just as much as you would have with a car, a new car. And as the car gets older, we have to take it in for a technical review. And also what we do every day as pilots, we are required to perform a visual check before every flight. Normally, depending on your company, the captain will make the check first, and then any subsequent checks. For example, you're flying Bogota, Cali, Medellin, the first officer will do, I've done the main check in the morning to make sure everything's okay. He can report if there's any problems. What's very important for us in the ICAO exams is understanding the word sudden or rapid. Many people omit these words in their readbacks, and that creates, obviously there's a difference between a decompression and a sudden decompression. There's a difference between a rapid decompression and a decompression. So look at these type of questions. How can a bird strike cause sudden decompression? Well, it's going to hit the window. It's possibly hit the window. That's going to create a decompression. It's probably going to hit the engines. That's going to knock out my pressurization system. What should be your first reaction? We're going to show you. And we're going to look at what events can cause, what can be the causes of sudden decompression. Again, remember that word unexpected? That's what sudden is. You didn't expect it, and it happens. Are you prepared? And for our passengers, that's why we always say to them, as we do in the flight deck, please keep your seatbelts fastened at all time when you're in the seat. Because what happens if we have a sudden decompression? We'll find out as we go through. Synonyms for suddenly, abruptly, unexpectedly. There's that word, all at once, all of a sudden, out of the blue. That's a great English word. It hit me out of the blue. I didn't expect it. Suddenly, abruptly, accidentally, out of the blue, by chance, and of course, rapidly, quickly, fast. It happens so fast you didn't know. Are you ready? Are you prepared? Are you wearing your seatbelt?